Welcome to The Explainer. Today, we're diving straight into one of the biggest, most mind-bending puzzles out there. It's a mystery that has literally haunted philosophers and neuroscientists for decades. How does the physical, biological meat of our brains actually generate the vivid, colorful reality we experience every single day? Well, stick around because we're exploring a groundbreaking new framework that might actually have the answer. I want you to take a second and just look inward. Imagine the vibrant, glowing red of a stop sign or the sharp, sudden pinch of a needle. Now, a smartphone camera can process the color red perfectly, right? But it doesn't have an internal, subjective experience of it. It doesn't feel red. So why is there something it is like for you to be alive and experiencing things right now?
Let's set the stage with part one, the mystery of consciousness. Think about it. You've got this incredibly complex brain made up of about 86 billion physical neurons, and they're just sending electrical and chemical signals back and forth in complete darkness. How exactly do those biological switches create your vibrant inner world? This massive explanatory gap was actually formalized by philosopher David Chalmers back in 1995 as the hard problem of consciousness. You see, neuroscience can show us exactly which brain areas light up when you feel happy or when you recognize a face. But that still leaves a huge gap between firing neurons and the actual undeniable feeling of being you.
Historically, people trying to solve this have kind of split into two really extreme camps. On one side, you have substance dualism. This is the idea that the mind is this non-physical, almost magical entity, a ghost in the machine. But scientifically, that completely violates the laws of physics. On the flip side, you have eliminationism, which basically just denies that subjective experience is a problem at all. It writes the whole thing off as an illusion. But, try telling that to someone who just stubbed their toe. Neither of these approaches really gives us a rigorous, workable scientific framework.
Which brings us to part two, reframing the hard problem. And this is where the neuroscience theory of consciousness, or NTC, comes in. Originating from independent researcher Satyaprakash Dube's framework, NTC charts this revolutionary third path. Dube argues that the hard problem isn't actually a gap in nature at all. It's a conceptual artifact. Basically, we've been tricking ourselves by using two completely different languages to describe the exact same thing. We use a third-person biological language for the outside of an event and a first-person phenomenal language for the inside of that same event. According to this theory, there was literally never a gap to begin with.
NTC calls this idea biologically emergent monism. I know it sounds like a lot of jargon, but just think of it like water. If you isolate a single H2O molecule, you're not going to find the property of liquidity anywhere in it, right? A single molecule isn't wet. Liquidity is a macro property. It only emerges when millions of those molecules interact under the right conditions. NTC argues that consciousness is exactly the same thing. It is a biological macro property that naturally emerges when billions of neurons integrate in a very specific way. So it's completely physical, natural, and scientifically tractable.
Now let's move into part three, the brain as a transducer.
So if consciousness is just a natural biological property, what does it actually do? To wrap our heads around this, let's look at the human eye. Unless you've watched way too many sci-fi movies, you know there isn't some tiny person sitting inside your skull watching a movie screen. The eye doesn't compute math. It doesn't think about the philosophical meaning of light. It just acts as a transducer. It simply takes photons from the outside world and transduces them, translates them into electrochemical signals. It changes the medium, but it perfectly preserves the information. NTC applies this exact same logic directly to consciousness itself, calling it data-to-experience transduction. Your consciousness doesn't solve math equations or move your muscles. Your motor cortex handles all of that. Its sole biological function is to transduce integrated neural data into internal experience. When brain activity reaches a certain level of complex global integration, its intrinsic nature, from the inside, is simply experience. The medium itself is the message.
All right, let's get into the gears of this in part four, the mechanics of experience.
How is an experience physically put together in the brain? Well, NTC built its foundation on a very well-supported model called the Global Neuronal Workspace Theory, or GNWT. GNWT states that your brain has this vast, distributed network of long-range connections. When a piece of neural information becomes strong enough, it sparks this widespread ignition event, broadcasting that data globally across the brain. Now, from the outside looking in, this is just a measurable electrical spike. But NTC posits that from the inside, this broadcast is exactly what it feels like for something to become present in your mind. Let's break this down with a super relatable example, stubbing your toe. We've all been there. First, those pain receptors send nociceptive signals rushing up your spinal cord to a central hub in your brain called the thalamus. Next, the thalamus distributes those signals out to your cortex. And third, the moment that pattern of activity crosses a specific integration threshold, boom, it triggers that global ignition. In that exact fraction of a second, raw neural data is transduced into the sudden, inescapable, subjective feeling of pain.
But hang on, why does stubbing your toe feel like a throbbing pain, while looking at an apple feels like seeing the color red? NTC proposes a really fascinating answer: neural geometry. The specific, unique quality of any experience comes down to the literal, mathematical shape and trajectory of the neural state within your brain's conscious subspace. The intense redness of red and the awful painfulness of pain are simply the subjective characters of entirely distinct geometric neural patterns.
Finally, let's talk about the science in Part 5, testing the new theory. What makes Dubé's NTC so exciting is that, unlike purely philosophical arguments, it is empirically testable. It acts almost like an ontological layer built right on top of the current academic landscape. We already have theories like GNWT, which explains how information gets broadcast. We have integrated information theory, or IIT, which measures the complexity of a system to determine the existence of an experience. NTC doesn't try to replace these, it builds on them. GNWT shows us the mechanism for access, but NTC explains the constitution, what that global ignition intrinsically is from the inside. Because this is fully grounded in physical neuroscience, it makes highly specific predictions that we can actually test in a lab. For instance, NTC predicts a measurable threshold of complexity, known as the PCI threshold. And if you drop below it, consciousness just simply turns off. It also dictates that absolutely every single conscious experience requires a detectable global ignition event. No ignition, no experience. Even wilder, it predicts that with advanced decoding, we're going to be able to map specific felt qualities directly to specific neural geometries. And lastly, it predicts that if you disrupt certain metacognitive networks, it actively destroys the forminess, that personal, subjective nature of an experience. This isn't just theory anymore, it's measurable scientific reality.
So, what does this all mean for us? If NTC is right, that seemingly impossible explanatory gap between mind and matter is finally closed. The hard problem was just a trick of language, and our beautiful, subjective experience is really just the inner life of an integrated biological machine. But it leaves us with such an incredible, provocative question as we look to the future of neuroscience. As our brain scanning technology gets better and better, what is the exact geometry of our feelings? Because one day, very soon, we might literally be able to map the shape of love, the curvature of a sunset, and the mathematics of a memory. Something to think about.